So today we're going to talk about series and parallel connections in for solar and solar electric panels and for batteries. So series and parallel, the reason why we have to think about series and parallel connections is because solar panels and batteries come in discrete capacities, certain number of volts. They produce a certain number of amps, or in the case of batteries, they have the capacity to store a certain number of amp hours or kilowatt hours. And so if you need something that's outside of the discrete quantity that battery or solar panel comes in, you need to hook them together in the system. So solar electric system design is really the process of selecting components, batteries, panels, charge controllers, inverters, wiring and wire sizes, protective devices, and metering, in specifying how they will be connected to reliably provide a load. And these connections often involve series and parallel, understanding what series and parallel connections are. So you need this in order to be able to design solar electric systems. So for when I talk about standards and discrete voltages that things come in, you have to match whatever you're going to design the system for. So for an off-grid DC system, for example, the standards are 12 volts, 24 volts, and 48 volts. Now a off-grid system could have a DC side, and if it has an inverter, it would also have an AC side. AC side, the standard would be 110 or 110 or 120 240, 110 to 120 or 120 240 as the options there. And we'll talk more about that when we talk about AC, so you can understand what this option of 120 240 is, but that's a standard for AC. And for grid-tied systems, you have a grid-tied system that doesn't have any batteries. It can only put power out to the grid when the grid is there. On the DC side of that system, in other words, from the solar panels to the inverter, it's typically 300 to 400 volts is the standard there, and we'll talk more about how that works. So you have to hook solar panels up to meet these, these voltage standards that you're designing the system around. For batteries, here's a picture of a typical battery that's used in a small solar electric system. They come, the standard voltages for batteries are 2, 6, and 12 volts. The basic electrochemistry of a battery, of a lead-acid battery, first off, any two different metals that you put in a weak acid or a weak base will make a battery, and the voltage of the battery, the inherent voltage that you get when you put those two metals in the weak acid or weak base, is related to the materials you're using. And for lead acid batteries, it's 2 volts per cell. So any lead acid battery that's above 2 volts is actually a combination of separate batteries put into one package. So for example, this is a Trojan T105 battery, and it is 6 volts and 225 amp hours, weighs in at a hefty 62 pounds. And you see it has 3 caps on it because it's actually 3 separate batteries. So this is a 2-volt battery, this is a 2-volt battery, and this is a 2-volt battery. So 2, 4, 6 makes a total of 6 volts. So typically with lead acid storage batteries, and that's the most common that you will find, that you can tell how many cells they are by the number of caps they have on the top. Now here's a battery that's 2 volts per cell. Note it only has 1 cap, and it's the Rolls Charette 1860. That means it has 2 volts, 1860 amp hours, and weighs in at a hefty 131 pounds. I've had to move these around, and you wouldn't want to do it all day. And then individual batteries get connected into a battery bank. So here's a battery, and they get connected into a battery bank. And again, here's a battery, they get connected into a battery bank. We'll talk about how you can design that. For solar electric panels, we have the same kind of situation. So here's a individual panel, and it gets connected into an array. And so here's a 12 volt solar panel, one solar panel, and then that needs to get connected into, if you need more capacity, into what's called an array. And so with batteries, you connect them together into a battery bank. With solar panels, you connect the panels together into an array. Now, so step 1 is to match the components, connect the components so as to match the system voltage. And in this case, what you need to do is you need a series connection. I'm going to explain that. So the idea with a series connection is the positive of one battery gets connected to the negative of the next battery. And in series, voltages add. So let's see how that works. So we connect the positive of this battery to the negative of this battery. Then we're left with two terminals, a positive and a negative. It's almost like it's made into one big battery. And in this case, it's 12 volts between the two terminals that are left, because we go up 6 volts here from the negative terminal to the positive terminal. Then we go across here, get connected to the negative terminal again, and we go up 6 more. So if we actually measured with a voltmeter, we'd measure 6 volts here. And then if we measured over here, we'd measure 12, because we're adding those voltages up by connecting in series. So in series, you connect the positive of one device to the negative of the next device in the string. And it's called a series string. And again, remember, the two things to remember is the positive of one connects to the negative of the next, and the voltages add. So let's look at this situation for a 24-volt system. So here's 2 batteries, 6 volts. Well, if they're going to add, we can't make 24 volts with 2 6-volt batteries. We can only get 12 volts, so we'll need 4. So here's 4 batteries. So let's connect them up. So we connect them up, we got 12. If we measured from here to here, we'd get 12 now. If we measured from here to here, we'd get 18. And then again, we connect the negative of this one to the positive of this one. Again, we've done that all the way across. Negative of one to the positive of the other. Negative of one to the positive of the next. Negative 1 to the positive of the next. And then finally, we're left with two terminals, the negative one here and the positive one here, with 24 volts in between them. 6, 12, 18, 24 volts. Now, one thing is very, very, very important to remember for safety around batteries is that you never, ever, ever want to connect the positive of one battery to the negative of the same battery, because that'll create a short circuit and something bad will happen. You may get burnt. There may be an explosion. Depends on how big the battery is and how strong the connection is that you make across here. This is a very bad safety problem, and I'll just make sure that we understand that by saying never connect this to this. Never, ever, ever do that, even by accident. Okay. So if we look at series connections with PV panels, let's say we have two 12-volt panels. How do we connect them for 24 volts? Remember, a series connection, plus goes to minus, and the voltages add. So see if you can think of how these would be connected. I'll give you just a second to think about that. How would you connect these up? Where would you make the connection so that where they add up and make 24, and then where would you take the power off when you're done? So I'll give you a second to think about that. Okay, I'm back, and did you figure it out? Here, so first we could take the positive of one, connect it to the negative of the next, and then we would take the power off here and here. Let's say over here, in between here we'd have 24 volts. Pardon my drawing capability here today. And from here to here is 24 volts. And, one of the things that's important to think about is how can you draw this in such a way that it's easy for a person to understand. Now, it might have been better, let me see if I can go ahead and do this really quickly. If I drew it, if I wanted to be able to easily compare it to the batteries, but if I had drawn these two like this, let's just move this out of the way. If I had drawn these two like this, put them in this relationship, then you see how easy it is to connect the positive to the negative. In this case, we would only have to, let me just bring that back. So in this case, you can see how much easier it is to see this series connection than, whoops, let me see. Come on, whoops. Because all I have to do, there it is. So, I want the pen, pointer options, pen, right? All I need to do is connect the positive of this to the negative of this, and then I take the 24 volts out here and here, and this is just so much easier to see. You can see the series string right here. You can see that there's a series string, and you can see where it takes off. So how you draw these makes a lot of difference in how easy it is to see what you're doing, and it takes a little bit of practice to figure out the best ways to draw connections like this. So again, this is the same thing. There's nothing wrong. It's just, again, a little less clear to see when a little less clear when you're taking the power out, how everything is connected. So now we know how to connect for proper voltage. And then the next thing we have to think about is what's called a parallel connection. What if you already have the proper voltage, but you need more capacity? So let's say you're building a 12-volt system, and one battery isn't enough storage. You need to connect two batteries. How do you connect those? Well, that's when we have to talk about parallel connections. So in parallel connections, plus connects to plus and minus connects to minus. And in this case, the current or amp hours add, but the voltage stays the same. So so plus connects to plus, minus connects to minus. The current or amp hours add, but the voltage stays the same. So how does that work? So here in this situation, we've connected the plus to the plus and the minus to the minus, and then we can take off here 12 volts. And we would have then, if this battery was putting out 5 amps and this battery was putting out 5 amps, then where they join here, they would add to 10 amps is what you would eventually take off. So in this case, the currents add, but the voltages stay the same. And again, you're connecting the plus to the plus and the minus to the minus. When do you do this? When you already have a component that's at the right system voltage, but you need to add more capacity. You need to add more current, typically, or more storage, more amp hours to the system. So if each battery is 100 amp hours, then the total, so this is 100 amp hour, 12 volts at 100 amp hours. This is 12 volts at 100 amp hours. Then out here, and this whole system would have a total of 100 amp hours. 200 amp hours out of the whole system when they're connected like this. So the amps add and the amp hours add. And we'll talk a little bit more about amp hour, what amp hours are. Maybe I should say that right now. So the storage capacity of batteries is the unit of measure of the storage capacity is the amp hour. And what that means, what 100 amp hours means, is that if I'm taking 5 amps out of this battery right now, and it's a 100 amp hour battery, then I could take that out for 20 hours. So the amps times the hours equals the amp hours. So if I was taking 10 amps out of this battery, and it's a 100 amp hour battery, I'd only be able to do that for 10 hours. If I was taking 30 amps out of this battery, and it's a 100 amp hour battery, I'd only be able to do that for 3.5 hours, something like that. So, and it's the same situation if I was filling the battery. If the battery was empty and it's a 100 amp hour battery and I'm putting current into the battery, then it's going to take me 20 hours to fill it up if it's a 100 amp hour battery and I'm putting current in at the rate of 5 amps. So that's how amp hours work. It's a unit of storage. So let's say that we've got here's an example of 6 volt 200 amp hour batteries connected in series to make a 24 volt 200 amp hour battery bank. Now again, in series the voltages add, but I didn't say this earlier. The amp hour capacity or the amps flowing through one battery are the same as the amps in all the batteries. So in this case what we've done is we've added the voltages by hooking them up in series, but the amp hours of each battery is the amp hour of the total bank. So this is a 200 amp hour 24 volt battery. If each of these are 200 amp hour batteries, and that's a typical amount for a where are these lead acid batteries that are used in solar storage come from, or manufactured on a large scale, is they're used in golf carts and they're used in forklift trucks. So a standard golf cart battery is 6 volts and 220 amp hours, one like the one we saw earlier. And these are quite common in solar electric systems. And so that just to let you know, this is a fairly real example. So again, adding in series, putting them in series, the voltages add, but the amp hours stay the same. Now, let's say I want to do 24 volts, but I need 400 amp hours. So then what I'd do is I'd create another 24 volt 200 amp hour battery bank by connecting 4 batteries in series. So I have one here, I connect in a second one, so then I have these 2 series battery banks just hanging out here. And then I connect them up in parallel. So I connect the plus of this to the plus of this one, and the minus of this one to the minus of this one, so that when I come out here, I have 24 volts, okay, the voltage across the series string, but I have 400 amp hours because I've hooked the 2 strings up in parallel so that the amp hours add. Okay, and we'll do some examples in class to try to make this a little bit clearer. So here's example with PV panels. So one panel, let's say it's 12 volts and 5 amps is what it can put out in full sun. It's a 12 volt panel inherently, and it'll be 12 volts almost regardless of what the sunlight is. But in different varying amounts of sunlight, it'll put out different amounts of amps. That's how solar panels work. So this solar panel then will be able to put out 5 amps in full sun. If it was half cloudy, then it would put out 2.5 amps like that. So this one panel, 12 volts, 5 amps. So if we then take those panels and hook them up in this way, what is the voltage and current here? And is this a series or a parallel connection? So I'll give you a chance to think about this. And remember, series is plus to minus, and parallel is plus to plus, minus to minus. So, and then remember in series that the voltages add, and in parallel the current adds. So again, remember these are 12 volt, 5 amp solar panels. So think about that for a minute. Okay, I'm back. Let's take a look at what this is. So this is a parallel connection because the pluses are all connected to the pluses and the minuses are all connected to the minuses. And in that case, in a parallel connection, the currents add. So each of these is putting out 5 amps. So here, if we measured the current, it'd be 5 amps. But after the second panel, we'd actually get 10 amps. And after the third panel, we'd get 15 amps. And after the fourth panel, we'd get 20 amps. So the total amount of current coming out to this whole parallel solar array will be 20 amps. And because it's in parallel, the voltages stay the same. So this is a 12 volt panel, 12 volt panel, 12 volt panel. It's 12 volts from one side to the other. There's no series connection here, so it's 12 volts from one side to the other. And we've added the amps up for 20 amps. So let's take a look. Here's just a couple of more examples. So each module is 12 volts, 5 amps. So in this case, we have, obviously, this is plus hooked to minus, so this is a series string. And there's put together, there are 12 volts in a series, the voltage adds, so this will be 12, 24, so we get 24, but this current stays the same, so it's 5 amps. And in this case, what we've got is we've got minus connected to minus, plus connected to plus. That means it's parallel. If you remember, parallel means that the voltage stays the same, the currents add. So again, these are 12 volts, 5 amps, so the voltage is going to be 12 volts, and it's going to be 3 times 5, 15 amps coming out here. And this one, if we look at this, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 solar panels, and they're connected negative to positive, negative to positive. That means that's a serial connection, series connection, and that means that the voltages add, but the current stays the same. So in this case, we'll have 12 times 8 or 96 volts, but it'll be the same current as one solar panel, 5 amps. Okay? And here's putting all this together into a kind of a system design. Here's a system that has 10 100-watt modules connected for 24 volts. It's a 24-volt system, so these are 12-volt modules. So you have to hook them to get 24 volts. You have to hook them together in groups of 2. So here's a series connection here, and so I get between here and here, I'll get 24 volts. Another series connection here, and between here and here, I'll also get 24 volts. Another series connection here, and I'll get 24 volts. Series connection here. So these are connected in groups of 2 with series connections, and then each group of 2 is connected together in parallel. So the plus of this one this group of 2 is connected to the plus of this group of 2, and the plus of this. So here's a group of 2. I'll just, circle it. And then there's another group of 2 here. Circle it just so you can really see this here. And another group of 2 here. Okay. And so you look at this group of 2 has a plus and a minus here, and the plus of this group of 2 is connected to the plus of that group of 2. And then minus of this group of 2 is connected to the minus of that group of 2, all in the same all the way across. So that when you come down here, you have 2 wires that will have 24 volts across them, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 times 7.2 amps. Maximum power is 5.2. So 5 times 5, about 25 amps will be coming into this charge controller. So we'd have to have a charge controller that's big enough to handle 25 amps. And then when we look at the battery bank, these are 6-volt batteries, and they have to be connected for 24 volts. So that means for 24 volts, we'd have to have 4 of them in a series string. So here's one series string with a negative connected to positive, negative to the positive, negative to the positive. And then we've got a positive and negative left on the end. Then we take another set of 4 batteries and connect them in a series string. And then we connect the 2 of those series strings together in parallel to get twice the amp hour capacity of each battery bank, of each battery string, into this battery bank at 24 volts. And so then you see other things here, like this is a breaker, meaning this limits the amount of current that flows through here, so that if there's a short circuit or some problem, it would burn this up before it burnt the wire. This is like a fuse. Here's one here, here's one here. So these are safety devices that you put between, especially around batteries, because batteries can, in a short circuit, deliver huge amounts of power. And so in this case, this system has a DC side where you can supply DC loads through a breaker, and it has an AC side where you can supply AC loads to an inverter and then to a house. So from here on out, it would be like standard, like a house that was connected to the power grid, except it's got the sun on the other side of it. And we'll talk about, also we have to talk about how big these wires are. And that's going to be another discussion. But what you want to do is you want to design the wire sides so that there's less than a 2% voltage drop from the PV to the battery bank, and less than a 2% voltage drop from the battery to the DC load, and less than a 2% voltage drop from the battery bank to the inverter. And so we'll talk about what that means. But just to show you how this all fits together. Maybe it's a little complicated. Maybe I can let you just look at this for a minute. And I think this is pretty much the last slide, yeah. So I'll let you just look at this for a minute so you can kind of think your way through it and see if you can see the series and parallel connections here in the solar panels and the batteries, and how the voltages add in series, and then those, to get the proper system voltage. And then once you have the proper system voltage, you have to add the capacity. Oh, one thing I wanted to point out on the battery bank is that you can't put, this is for 8, you can't put 10 batteries in this system. You have to put them in groups of 4. So if you had 10 batteries, the 2 of them wouldn't be usable. So you'd have to, if you wanted to add more capacity here, you'd have to have a 12 battery system. If you wanted to go beyond that, you'd have to have a 16 battery system. And so you can and also with solar panels, you'd have to have at least 2 of them connected in order for this system to work. So you couldn't have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 panels. You couldn't have 11 panels in this system. Just point that out. So take a look at this and see what you think, and then we'll close up this lecture. Okay, I'm back, and just want to close this out with this famous "Resistance is Futile" poster, and we'll be having, just to remind you, we'll be having a basic electronics lab at the end of the week, where you'll learn a little bit more about resistors and other things. And that's the end of the lecture.